All right, this video, we're going to cover Section 8. I'm going to cover it all in one video. Section 8 is a summary of functions. So we're going to talk about linear functions, quadratic functions, and exponential functions. We're also going to talk about piecewise functions and talk about arithmetic sequences and geometric sequences. Those will be the highlights from this video. So let's start off talking about linear functions. All right, linear functions, you're going to notice that they go up by the same amount every time. All right, so if x goes up by 1, which it does every time on this left-hand side, y will go up, or f of x will go up by the same amount on the right-hand side. So 5 to 7 is plus 2, 7 to 9 is plus 2, 9 to 11 is plus 2, and 11 to 13 is plus 2. All right, so linear functions, every time that x goes up by 1, f of x or y will go up by the same amount. Quadratic functions. All right, quadratic functions are a little bit different. You're going to notice that the first time that you find the sum here, so again, x is going up by 1 each time, our f of x went up by plus 1, then plus 3 from 4 to 7. From 7 to 12 would be plus 5. And from 12 to 19 would be plus 7. All right, so we notice that those are not the same. But if you go to the second difference, all right, 1 to 3 is plus 2, 3 to 5 is plus 2, and 5 to 7 is plus 2. All right, so the second difference right here, that will be the same in quadratic functions. All right. Linear functions, we've seen them multiple times in class. All right, it would be a straight line. And this right here, we could say would be y equals 2x. All right, it's going up by 2 each time. And then the y-intercept is this plus 5. All right, so it might be an equation like that. All right, the quadratic function. All right, key features of a quadratic function would be that something would be squared. All right, so it's always going to be to the second power. All right, the second power. And quadratic functions form a parabola. All right, and they have a vertex. That's when the graph shifts from decreasing to increasing. All right, it has a change of directions at the vertex. All right, then we look at exponential functions. If you notice here, you multiplied by 3 each time. 1 times 3 is 3, 3 times 3 is 9, and so forth. All right, and exponential function is going to approach 0, as you see down here. All right, so as x is decreasing, all right, y is approaching 0. It's not going to touch 0, but it will approach 0. All right, and it will look something like this. F of x equals, you're going to have your y-intercept, which in this case is 1. All right, and then it's going to be multiplied by whatever your common difference is, so 3 to the x power. All right, so that would be basically what you're looking at there. All right, so if you see something to the x power, you know it's exponential. All right, the next thing that we're going to look at is determining whether it's quadratic or not. All right, quadratic, linear, or exponential. So this first one is quadratic. If you notice, 1 plus 2, you added 1. 2 plus 5, you added 3. 5 plus 10, you added 5. And 10 to 17, you added 7. So this first difference is not the same, but the second difference is plus 2 each time, and that lets you know it's quadratic. All right, then the next one, they added 6 each time until this last one they added 12. That might throw you off at first, but if you notice, the x was plus 3, plus 3, plus 3, and then it went plus 6. So that's why it went plus 12 at the last one, because x went up by a different amount. All right, but every time that x goes up by 3, y goes up by 6. All right, Then we're going to look at that last one, and we notice it's times 3 every time. 2 times 3 is 6, 6 times 3 is 18, and so forth. So that lets you know that is exponential. All right, if you're just looking at real world examples, anytime that something is growing, all right, that is going to be modeled by exponential, all right, an exponential graph. All right, if something is going a certain speed, all right, so you see certain speed here, that's the key word. That means it's going at a constant speed, and that's going to be modeled by a linear graph. Kicking a ball in the air, all right, so you kick it, it starts off at ground level, it goes up in the air, and then comes back down. All right, that's a quadratic. Running a race, again, constant speed, lets you know that that is linear. All right, the other word that lets you know that it's exponential is decay. All right, anything that's decaying is going to decay exponentially. All right, and then jumping from a high dive. In this case, you didn't start at ground level. You started higher up on maybe a diving platform. You jumped, so you went up in the air and then came back down. Again, that's a parabola, so that would be modeled by a quadratic. All right, the next thing is noticing that geometric sequences follow an exponential pattern. So option 1 right here, all right, it follows a exponential pattern where it's going up slowly, but then it's compounding and then dramatically goes up. So that's an exponential pattern. All right, arithmetic sequences, option 2, all right, that goes up by a linear pattern. So arithmetic sequences follow a linear pattern. All right, so if you're reading it in a real world example, all right, Pablo and Lily are saving money for their senior year trip next month. Pablo's goal is to save 1 penny on the first day and to triple the amount. All right, so tripling tells you that he's going to multiply by 3. All right, and when you are multiplying, that will be a geometric sequence. All right, Lily's goal is to save $10 and increase that amount by $5 each day. So that's going to be constant, and that would be a arithmetic sequence. Again, arithmetic sequences follow a linear pattern, whereas geometric sequences follow an exponential pattern. All right, and the last thing that I want to go over is piecewise functions. All right, so piecewise functions would be something like this, where the graph is broken up into pieces. All right, this one has 2 pieces. All right, the first piece, we see something squared, so that we know that that is a quadratic. All right, and this graph follows a quadratic model whenever x is less than or equal to 0. All right, so less than or equal to, we have that closed dot here. Anything to the left-hand side is where it follows that quadratic model, all right, where it makes like a U or half of a parabola. Then if you switch to when x is greater than 0, we see this straight line. It's linear. We have an open circle right there, so we know that 0 is not a part of the second piece, it's a part of the first piece. All right, we also see this +1 lets us know that it has a 1 y-intercept. All right, and it's going to increase by 2 every time that x increases by 1. All right, so if it told us to evaluate f of 2, all right, well, 2 is greater than 0. So if I evaluate f of 2, I'm going to use this linear function. I'll plug in 2 for x. So f of 2 equals 2 times 2 plus 1. 2 times 2 is 4 plus 1 gives us 5. If it said evaluate f of 0, all right, 0 is a part of the first function, all right, when x is less than or equal to 0. So I would use that quadratic function. So x squared minus 2. F of 0, I plug in 0 for x, so 0 squared minus 2. 0 squared is 0, minus 2 equals -2. All right, so that lets you know which one of the pieces that you would use based on what you're evaluating for. All right, so that's all for this video. If you have any questions, leave them in the comments, and then also post your name in the comment section so I can give you credit for watching the video.